I wish to welcome you all. We'll be starting within a minute. Let's give the people a couple of seconds so we could have most of you at the start. Okay. So good afternoon, good morning, ladies and gentlemen. Welcome to this webinar about the selection of 2P tracker technology for the MEA region in the era of larger PV modules. This webinar is sponsored by Arctech, one of the world's leading manufacturers and solution providers of solar tracking and racking systems. And we are happy to have Jinko Solar and TÜV Austria on board, and I will be introducing our guests soon. In the beginning, just to make sure that everyone hears me clearly, can you please confirm that in the chat or in the comments of the live broadcast? If you are on LinkedIn, Facebook, Twitter, YouTube, then please write in the comment if you can hear me clearly or not. And if you are here on Zoom, then please also let me know if you can hear me clearly. I see Marwan, Sarah, Ahmed, Yo, Werner. Excellent. Okay, you can all hear me. That's great. Thank you very much. So the same function that you use now, please use it to communicate together, to introduce yourselves to the others, but please don't send your questions there. If you have any questions, send them in the Q&A section, so we'll make sure that we can track them and we can answer all of your questions by the end of the session, even if we have to extend a little bit. And if you are on social media, then please send your question in the comment section below the video, and our team will pick up the questions, forward them to me, and I'll make sure that we answer that in the end of the session. Just please answer your question or ask your question in one block, in one block, full question, so we can take that in the end of the session. I'll introduce myself in the beginning. My name is Munif Barakat. I'm from Solar Arabic, which is the biggest renewable energy platform in the Middle East and Africa region. We'll be accompanying you today to discover how the PV tracking technology developed over the last few years to accommodate the bigger form factors of modern modules and to improve the economics of projects and the reliability of the PV plants. We will have a special focus on the 2P tracking systems and their applications in the Middle East and Africa. Arctech will be presenting today their latest technology, the SkySmart 2, as a solution for both the challenges of larger form factors of the PV modules and the harsh environment in the Middle East and Africa. For this, I will start introducing my guests by order of appearing in the session. Our first speaker will be Mr. Mohammed Saadi Dweik, who is the head of technical services and product management at Jinko Solar. Our second speaker is Mr. Noor Hamad, who is an industrial sector inspector at TÜV Austria or TUV Austria. And finally, we will have a detailed presentation from our speaker, Mr. Amrendra Singh, who is the technical sales lead for the MEA region at Arctech. I believe that most of attendees have already joined the session. We've done the introductions from our side, so we'd like to know a little bit more about you. And for that, we'll be running a couple of poll questions to answer us from what region you joined us today. So if you are in the chat, please just write the name of the country where you live or work, so we can know where you joined us from today, and we could tailor our content. So far, I see that 25% are from the GCC countries, 22% from the rest of the Middle East, 37% from Northern Africa. We have also 10% from the rest of Africa. We have people from Europe, from Asia. And I'm very happy to have you all on board. I stopped the poll, so we go quickly, and I ask now the second and the last question, where we'd like to know what area are you active in? So if you're a developer, an EPC, service provider, an investor, or if you're from the public sector or a consultant, then that would be all helpful for us to tailor the content as we go. And if you are on social media, then please write, let's say, your role, or in what area is your company active, as a comment under the video so we could get to know you better. I see that approximately we have three major, let's say, segments here, to around 20% developers, 20% EPCs, and 11% service providers, and 14% consultants, which is a very nice mix, let's say, of expertise that we have in here. And I expect a lot of good questions from you. So please ask your questions in the Q&A section as we go, and don't delay them till the end. Just ask them there and we'll make sure to pick that up in the end of the session. So without any further ado, I'd like to hand over the presentation to Mohammed Saadi from Jinko Solar to start with the first part.
Thank you for the introduction, Munif. Hi, good morning, good afternoon, everybody. It's a pleasure to again be with you this year. First, thank you for Arctic for inviting me for this very important topic. And I hope I will be able to give a very valuable information for our attendees today. And now, since we are nearing also the end of 2022, I wish everybody attending this webinar had a very happy and fruitful year on both professional and personal levels. So without further ado, I want just to highlight a few trends that happened in the last few years from the solar supplier point of view. Before we do that, just let me very quickly introduce our company, Jinko Solar. Jinko Solar is one of the leading PV module suppliers globally, established in 2006, and it was named the biggest supplier in terms of shipment for 4 consecutive years. So far in 2022, we are the biggest supplier in the first half of 2022, at least now. We are waiting for Q3 and Q4 results. And so far, we are the only company, we are the first company, sorry, to reach the 100 gigawatt of shipments. And we reached it in Q1 this year. As a landmark year for Jinko Solar, we reached 20 world records in terms of cell conversion efficiency, and our capacity is 50 gigawatt of module shipments this year. Our portfolio is mainly the PV modules, our core business, both on P-type and N-type TOPCon. We have the storage solutions from residential small units up to commercial and industrial medium-sized units until we reach the utility scale units, which it's usually more than 1 megawatt hour. And we have also the building integrated photovoltaics, which we are shipping currently the biggest project in the MENA, Dubai Electricity and Water Authority new headquarters, Ashira building in Jeddah in Dubai, where we are shipping 5 megawatt of PIPV modules. So after this introduction, if we look at the global market of PV modules in the last few years, we have seen that the PV modules have went into a drastic improvements. And if you are following the market even more than 5 years, you will see that before the improvement were slow, were limited, but in the last 5 years, actually, the improvements were huge. So improvements first on the cell technology. So we went from the standard polycrystalline modules to the standard monocrystallines. Then we went into the PERC. We are going into TOPCon and other advanced technologies. So the standard 2x1 module, which used to give 250 watt, maybe it will give now 450 watt. So there's a huge improvement technology, but not only on the cell technology, the improvement, but also on the cell size. So, and this, of course, due to the improvement and development of the wafer manufacturing, because before it was, and for a long period of time, 156 millimeter used to be the standard for more than 5 years or even 10 years. This used to be the standard in the market. nobody was even considering going beyond this. But now we see the development in the manufacturing process. So now we are able to reach 182 and even bigger wafer. So of course, this led to have a bigger modules. So now we have modules above 600 watt instead of having only 300 or 350 in the past. Now we have modules with 600 and more. And of course, this is the main challenge, that the development of the PV module was very quick. So sometimes, we forget that we need also to check the development of other components of the PV power plant. So we have inverters, we have the trackers, and of course the structures. So not every company was able to cope with and to follow this trend. So having a bigger modules, of course, it's a mutual benefit for both PV supplier and the client, because installing one, for example, 500 watt module is better than installing two 250 watt modules. In terms of manpower, shipments, it's better. And also for us, manufacturing one 500 watt module is better than manufacturing. So, but of course, the challenge of having bigger modules is having a module that will have more mechanical load, will expose to more wind. So you need more strong module. And this is the first challenge for the tracker and structure suppliers. They needed to adapt and they needed to improve. And this is something Arctic also will highlight this. And the second thing that became also a trend in the market, especially for utility projects, is the bifacial modules. Now, when I say bifacial modules, I'm talking about modules that can generate electricity on both sides. Although the front remain the major source of generation, but the rear side can contribute up to 20 or 25%, depending on many factors. So when we have a bifacial modules, additional considerations should be happening when you design your power plant. You need to have more ground clearance. So the height should be more, at least 1 meter. The distance between the rows should be also considered and increased. And also the albedo or the ground reflectivity also should be considered. So this is also another challenge for trackers, because they needed to adapt their modules to maximize the rear side generation. I remember back in 2019, we didn't have, it was only once or two suppliers were having a compatible bifacial trackers for bifacial products. But now, of course, we see the market is adapting to this, and we see Arctic also is one of the leading companies to direction. So either it's 1P or 2P, all the tracker companies should adapt their production, because the challenge is to maximize the rear side generation when using trackers, and also not to have a rear side shading from the structure, or minimize the rear side shading from the structure on the PV module. So it's quite a challenge, honestly speaking. And I'm glad that the combination now of bifacial modules with trackers has become the standard in the utility. So now when you see any new project in the region, whether it's in Qatar, Saudi Arabia, UAE, Egypt, Morocco, when we talk about any new utility project, anything above 50 megawatt, it's always bifacial with large modules with trackers. So it's the winning combination for utility projects. So as I said, the challenge of having bigger modules is from the tracker side, and this is something Arctic will highlight in more details, that you need to have a stronger trackers, you need to have more purlins, you have to have more posts, and you need to have bigger motor in order to be able, because you have heavier modules. And of course, when you have more wind speed in some locations in our region where the wind speed is high, also you need to improve and to optimize the purlin and the post. So this is something I will leave it to Arctic to highlight how they were able to solve this challenge. But with all these challenges considered, and with all the cost associated and with trackers, because some people maybe it will have, I need to invest more because you need to have more complicated system, so you will pay more in capex, and also you will considerably pay more in opex, because the operation maintenance of trackers are considerably higher and more complicated than PV only or fixed structure. So maybe it's not worth uh, the investment. But actually, when we see the market, how it's become and how the standard this has become, and this is actually a report by Enel, the very famous Italian developer, that going to bifacial, choosing bifacial modules will improve, will decrease the LCOE by 2.7%, which is considered a very, very attractive figure. And also going with more uh, powerful or bigger modules will increase the LCOE by 1.94. So if we consider the the combination of bifacial and large modules, we are talking about more than 4.5% of LCOE improvement. So that's why, for sure, it's a winning technology and winning combination. So that's why everybody in the market is going into, for utility, is going into this direction. You don't see now any utility projects being now discussed or specified with fixed structure or with monofacial instead of bifacial. All the projects now in our region are going with trackers, big modules, and bifacial modules. And based on our studies we have done, to bifacial, you will get around 10% additional in our region, additional generation. And also, if we go from fixed structure to trackers, you will get 9 to 12% additional. So that's why when you go to the old standard, which is monofacial with a fixed structure, to bifacial with trackers, you will get more than 20% of generation. And this based on many studies we have done and many projects that we have observed. And I think Arctic will have more details about this. So this is from my side. I hope I was able to give a good overview of the solar market. Thank you so much for your time, and back to you, Munif.
Thank you very much, Mohammed, for the very valuable input in here and explaining the challenge, let's say, historically and how it has developed over the last few years. And I think you laid out the perfect ground for Amrendra from Arctic to talk specifically about the tracker technology and how it followed the development of the modules technology. I'll hand over to you, Amrendra. Very happy to have you on board. And we're also I would like to re-emphasize on the commitment of Arctic for the Middle Eastern and African region, and with their very successful track record doing the gigawatt level projects in the region. So I'd like to hand over to you to have a quick introduction about the company and to dive into the topic, please.
Thanks, Munif, for a nice introduction, and thank you, Mohammed, for providing insight about the bifacial part of the module. So hi, everyone. Today, I'm going to talk about selection of 2P tracker technology for MEA region in the era of large PV modules. So in this presentation, we will discuss about the challenges faced by 2P tracker due to application of large size module. We will also discuss about the special design requirement in the MEA region, and we'll discuss about SkySmart 2 solution of the Arctic, which is most advanced 2P tracker solution, and how this tracker solution can be a best fit 2P tracker in the current scenario. And we'll discuss about the we'll also discuss about the benefits of the SkySmart 2 in enhancing the LCOE performance. So quick overview about my company first. Arctic got founded in year 2009, and its headquarters is in Kunshan, China. It has employees more than 1,000, and so far we have installed more than 40 gigawatt project, and we have completed more than 1,300 projects worldwide, and our global reach is in more than 40 countries. Now, coming to the involvement of Arctic Tracker, we have started our tracker journey in year 2013 with linked row design, and that time linked row was very common and popular. Then we introduced individual row design in 2016 with SkySmart, which is first stupid tracker of Arctic, and this is also a flexible tracker having one fixed point. And then in 2017 we introduced Skyline, which is one pit tracker with individual row design, and in 2019 we introduced SkySmart 2, which is stupid tracker with multi-slow drive, and that is why we call it as a resist tracker. So because it has multi-slow drive technology. And in 2020, we introduced artificial intelligence plus SCADA in order to improve the power generation in solar PV plant. And then in 2021, we introduced a Skyline, which is one pit tracker of Arctic with multi-slow drive technology. So now coming to the challenges in the solar tracking system due to application of large size PV modules. Presently, we are in the era of very high power and large size modules. And if we compare with 2015, 2017 with the current 2022, then in 2015-17, we were getting a module size, cell size that was coming around 156 mm, and now we can see cell sizes coming around 210 mm, okay, which is equivalent to M12 module. So basically, cell size is increasing, efficiency of the module is also increasing, and that is helping in reducing the overall power project cost. Now we'll talk about the large size module impact on tracker design and on tracker dimensions. So if module size will get larger, then the tracker longitudinal length will also get larger, and longer will be the tracker chord length. Tracker will be more taller, and the span of the tracker will also be larger. The span means the spacing between post to post. And there will be two major impact on the tracker design. First is that it will violate wind tunnel test limitations, and second is that it will lower critical wind speed. So a common question can come in everyone's mind that what is the meaning of violating wind tunnel test limitations? So basically, as a tracker supplier, we design and we do the wind tunnel test on certain length of the tracker. And if due to the application of large size PV modules, if the length of the tracker exceeds the length that was considered in the wind tunnel testing, then we won't be able to use the same wind tunnel test coefficients. And that is why we say that it violates the wind tunnel test limitations. The second impact on the design is regarding the lowering of the critical wind speed. So it is important to first understand the meaning of the critical wind speed. So basically, critical wind speed is the wind speed and which the tracker reach the torsional deflection limit. Okay. So what happens that due to application of the large module, if the tracker length will get larger, so in case of traditional tracker, normally we have one fixed point, and in that case, fixed point to free point length will get larger, okay, and that will cause very high torsional deflection at, in fact, lower wind speed, and that's why we say that it will lower the critical wind speed, and tracker will not be stable at higher wind speed. Now we'll see the large size module impact on bigger wind tunnel test coefficients. So in case of a smaller module, the shape coefficients will also be smaller, but however, in case of larger module, the shape coefficients will get larger. Okay, so these larger shape coefficients will cause very high wind pressure on module and on tracker, and the windward pressure on the tracker and module will be larger. That will induce the vibration effect, and it can damage the module cell also. So far we have discussed about the challenges faced by tracker due to application of large size modules. Now we'll see the special design requirement in the MEA region. So our first most requirement which comes in our mind is the bifacial module compatibility with the solar trackers. Okay, as we know that when bifacial module combined with the solar tracker, it can provide the highest generation. And if you compare with the pixel solution, then the generation can be even more than 25%. So now we need to understand what are the parameters of the tracker that can affect the generation. So if I talk about the parameters, then pitch is one parameter that can affect the generation. And if we increase the pitch of the tracker, then Basically, we are increasing the reflected areas, and that can enhance the bifacial energy gain. And second parameter is basically height of the tracker. If higher the height of the tracker, more will be the reflected light that can reach backside of the module, and it will enhance the generation. Then we'll discuss about the mismatch factor, and mismatch factor basically depend. The mismatch on the current can happen due to the back shading, and also it can happen due to defects in the module. And now regarding the albedo, so albedo does not depend on the tracker. It basically depends on the ground condition. It depends on the reflection qualities of the light reflection qualities of the sand or soil, we can say. So for example, in case of sandy area, the albedo is normally in the range of 0.3. But if the soil can have whiter in color, then maybe we can get higher albedo values, and it can be even 0.6 or 0.7 if it can reflect more light that can reach to the backside of the module to enhance the generation. Now we'll discuss about other bifacial factor like rear set factor and set transparency fraction. So rear set factor, basically it depends on the aspect ratio, which is tracker axis height to the module weight. And basically what we have observed that in case of 2P tracker, it also depends on the spacing between module to module. So for example, if we increase the spacing between module to module from 0 to 200 mm, then it is possible to reduce the rear shed factor from 8% to 3%. Okay. And regarding the set transparent fraction, so this depends on the spacing between cells to cell and the spacing between modules to modules. If higher the spacing between cells to cells and between modules to module, then extra light will reach to the ground, and more reflected light will reach to the backside of the module, and it can enhance the generation. Now, another challenging requirement and a special requirement comes in the MENA region is the high wind speed. So normally we get very high wind speed in the KSA region, and if you see the wind map, then normally we see the wind speed even comes to 52 meter per second or 54 meter per second as per the site locations. And due to the higher wind speed in the MEA region, there is a chance of very high daily average wind speed at the site, and the tracker will move frequently to the stow position, and that will cause higher energy loss, and this will lead to lower plant generation and PR values. So solution is that we need to find a tracker that has higher operational speed, or we need to find a tracker that has higher go to stow wind speed, so that tracker will not frequently move to the stow position, and therefore it will be more in the tracking position to enhance the generation. Now, another requirement in the MEA region is compatibility of the robot with the solar trackers. So we need to understand first background and the challenges. Basically, in the MEA region, we can see a lot of sandstorms, and also there is a issue with water. We basically get very small rainfall, and because of that, there is a deposition of the dust on the modules, and that will lead to the loss of generation. Okay, and the generation loss can be even 20% also. And another problem is that due to the dust deposition on the module, there will be partial shading on the module, and there will be local overheating also that can even damage the modules. So because there is a small rainfall and we need a frequent cleaning of the module, so and there is a water scarcity also in the MEA region. So we need to find a solution for cleaning the module, and if we consider wet cleaning solution, then it may be uneconomical. Then robotic cleaning is the best option which we can consider here. And so we need to understand the compatibility of the robot with the water, with the tracker. What are the requirements from the tracker side that we need to consider? So first of all, tracker need to be integrated with the robot and with the existing SCADA. We need to define the tracking angle for the efficient module cleaning. Also, we need to have a provision of dynamic bridge, static bridge, return station, including the docking station as well. So far we have discussed about the challenges faced by the tracker due to application of large size module. We have also discussed about the special design requirement in the MEA region. Now we'll see and discuss about Sky Smart 2, which is industry's most advanced 2P tracker solution. and how this tracker solution can overcome all the challenges. So this tracker, SkySmart 2, is basically independent road to pit tracker, and its length is up to 95 meters, and its core length is 5 meters. So this is this is world's first IC certified tracker with a synchronous multi-point driving system. It means we are considering more than one slew drive. So basically, we are considering up to 3 slew drives in one tracker, and because of the more number of the slew drives, tracker is basically very rigid, and it can reduce the torsional deflection at even higher wind speed. And this tracker has strings up to 4, and it can accommodate up to 160 modules per tracker, depends on the module size and design. Now, if we talk about the key innovations in SkySmart 2, so as I have already described, that this tracker has a synchronous multi-point driving system. So fixed to if the tracker length will get larger due to application of large size module, then still the fixed to free point length will be smaller. Okay, and it can control the torsional deflection even at higher module sizes. And it has shorter span, and therefore it has smaller deflection. And because of that, the critical wind speed of the tracker will be higher. The another innovation in SkySmart 2 is that it stores at 0 degree. So because at the 0 degree, it will get a lower wind pressure, and it will get a lower wind forces. And because of that, the tracker will be lighter in weight, and it has better cost structure. This tracker also has up to 4 strings per tracker that help in better electrical match and convenience. So now we'll discuss about SkySmart 2 compatibility with the critical wind speed. So as I have told you that this tracker has multi-slew drive, okay? So that will resist the torsional deflection, okay? And because of that, it has very high critical wind speed at different angles. So if I talk about the wind speed values, then it can be from 40 meters per second to 70 meters per second at different angles. And if I compare with the traditional tracker, which has only one slew drive, okay, this will cause, because of the one slew drive, there will be higher deflection, torsional deflection, even at a lower wind speed. And that is why its critical wind speed is lower compared to SkySmart 2. So its critical wind speed is in the range of 20 meters per second to 50 meters per second at different angles. Now, moving to the next slide, now we'll discuss why we have chosen a stow at 0 degree and not at another stow position. So basically, we have done the wind tunnel testing, and we have found that for the rigid tracker, where we have considering more than one slew drive to make it rigid, as per the wind tunnel test, we found that at 0 degree position, the critical wind speed of the tracker will be maximum. So this is the best position for the tracker, best safe position. And also, because of the higher critical wind speed, we have recommended the stowing wind speed also 20 meters per second, which is itself high compared to the traditional tracker. And higher the stowing wind speed, it means tracker will less go frequently to the stow position, and there will be more tracking time, and therefore more energy yield can be possible. Now, the another advantage of using SkySmart 2 solution is that it can adopt up to 20% ground undulations, which is among the highest level in the industry. It is a more flexible tracker, means it has more flexibility, and it can use maximum land. Now we'll discuss about the advantage of SkySmart 2 in number of posts per megawatt peak. So this tracker has fewest posts per megawatt peak, and there will be huge reduction in the foundation cost if you use this tracker. There will be huge reduction in tracker installation cost also, and there will be saving in time and cost also. And this tracker is a very good solution for the rocky soil strata, where it is difficult to do digging work, and where the excavation work is itself very challenging, and it can derail the project duration. And this tracker, since it stores at 0 degree, so it will have lesser wind pressure, and that will cause the less reaction forces, and therefore there will be saving in the foundation depth as well. Okay, now we'll discuss about how SkySmart 2 can help in enhancing the LCOE performance. So as I told you that SkySmart 2 has threshold wind speed 20 meters per second. Therefore, this tracker will less go frequently to the stop position. Okay. And therefore it has more tracking time. It means it can provide maximum generation. And second is that it is stored at 0 degree. It means it has potential to get more irradiation, including direct sunlight and diffusion light. And if I compare with the traditional tracker, then normally traditional tracker stores from 15 to 45 degrees. It means it may lose a great amount of irradiations when turning its faces away from the sun. Now, there is another way to enhance the LCOE. If our tracker has advanced artificial intelligence controller, and basically that works on two major strategy. First is the terrain strategy. Second is a cloud strategy. Okay. So if I talk about the terrain strategy, then normally sometimes we see very bad terrain condition at the side, and there will be a lot of undulations in north-south and east-west direction. So if I talk about undulations in the east-west direction, then because of the level difference in the tracker, there will be partial shading on the module. Okay. So our artificial intelligence control monitor the our artificial intelligence controller monitor the individual trackers, and if it found that there is shading on any module, then it gives command to the tracker to start the backtracking immediately so that it can avoid the backshading loss. Second is regarding the cloud strategy. So artificial intelligence based controller monitor the location of the sun in case of in cloudy weather, and accordingly it gives command to a tracker to rotate towards the sun so that it can face the maximum irradiations. Okay, and by this way it can enhance the LCOE performance. Okay, so far we have discussed about the benefits of the SkySmart 2. Now here we'll discuss the summary. Arctic SkySmart 2 has many fixed points. It has shorter spans and cantilevers. It is a very steeper structure. It has a small deflection. It has very high critical wind speed. It means high wind speed threshold values. It means it will less go frequently to the stop position. It has more time of tracking. It can help in more energy yield and more revenue. This tracker is stored at 0 degree, and it has a smaller pressure. It has lighter components and therefore more saving. Okay, so before concluding this presentation, I would like to give one message to the audience that for selecting any kind of tracker, we need to see the overall picture. We should not see only one or two aspects of the tracker. We need to analyze which tracker can provide the can help with the bifacial generation gain, and we need to see the electrical cost, civil cost, and structural cost of the tracker, and then we can decide which tracker is the best option. Thank you from my side. I'm ending my presentation here.
Yes, you can. Thank you very much, Amrendra, for the very informative presentation in here. You've generated a lot of questions in the Q&A section, which we'll be covering together. We had a third speaker planned for today's session, but he did not show up, so we'll continue to the Q&A section directly. This gives us a few minutes more to discuss approximately 20 questions that we have received. So in the beginning, I'll give you a little break, Amrendra. After the presentation, we'll start with a couple of questions to Muhammad, and then we'll get back to you with the tracker questions.
Sure.
Muhammad, we've received a couple of questions. I think they're more directed towards the bifacial modules. There's one saying, what is the general albedo values that we get in the MENA region, and how it changes from one soil type to the other? And there's a specific question about the carport application. If you install bifacial for a carport on an asphalt, then what is the albedo and does it make sense in your opinion or not?
Okay, so regarding the first question, which is a very important question for our region. If we talk about MENA, we are talking about desert mainly, especially in the GCC and also in Northern Africa. So usually the albedo of desert is something between 25 to 45%. So this can generate from maybe 8 to 15%, even little more of rear side generation for bifacial modules. Now, there are many factors contributing to this because the albedo is not a fixed value. It changes throughout the year. So the albedo of site during the summer is not the same as in the winter. Even if, for example, in practically in GCC, there is no winter, that you have sunny days all the time, almost all year, but that doesn't mean the albedo is the same. So usually the albedo is changing, and usually the values we have on BVSYST is like monthly average value, for example, or you can put also annual average value. So mainly, if we talk about the albedo, you talk about how light color is the ground. So if the ground is like yellow, light yellow, so it will reflect more light because the light colors like white, yellow, and other colors will reflect more lights compared to other grounds. So, for example, very quick example, if you have a grass, for example, if the grass is tall, it will have lower albedo. So that's why if you have a bifacial on with a glass albedo, you need to maintain the glass. You have to keep it short and not to be wet because the wet will reduce the albedo. So the albedo is a very complicated topic to highlight all the factors in, but to put it simply, the lighter is the better. So if you have like on the roof, for example, if you can have a white ground, you will have a very good albedo. Now, regarding the second question for carport, it's very useful to have albedo on carport, but this albedo is not related mainly to the ground itself, to asphalt, because as we know, for the carport, there are cars moving and cars parking. So actually, the albedo is very changing here. I cannot give even a very approximate estimate because it depends on how active is the carport and what the colors of the car, what type of cars. So it's very changing. But for example, I remember we shipped bifacial modules to Abu Dhabi airport 3 years ago, 3 to 4 years ago. And during that time, it was estimated something within like 7% of rear side generation. Because for cardboard, it's very complicated. You cannot have an exact estimation really. So it's not related to asphalt because asphalt is one of the options when there is no car parking. But if you have cars moving and parking, then you have different scenarios. So it's better to have white cars moving in the carport, so you will have a better albedo.
Yeah, that's a good point. I think one of the challenges of carport is this, let's say, non-uniformity, let's say, of the albedo throughout the day. Thank you, Muhammad. I'll move then to a couple of questions about the tracker systems and then get back to you. I've received a few questions regarding the presentations. We'll be sharing them by an automated email that you will get from Zoom within 2 days. So whoever is on Zoom will get that email for sure. Mr. Ahmed Mansour, I'd like to ask you to ask the question in the end. You explained the case, but I did not get the question in the end. If you can send it, then we'll be happy to ask it to our panelists today. Now I'll move to you, Amrendra, please, for a couple of questions.
Okay.
The first one, like you've talked about this difference between the typical tracker solutions that are in the market that have a stowing speed of like 15 to 17 meter per second, while you have a stow like at Arctic, the developed product with a 20 meter per second stowing speed. So that's few seconds difference. Is it relevant in our Middle East and African region or not?
Yeah, so we need to understand first why there is a difference in the stowing position. Basically, if I'm talking about the Sky Smart 2, so basically this is a this is a rigid tracker. It has a multi-slew drive technology. Okay, so
Mhm.
it can help in resisting the torsional deflection in the tracker. While in the market, normally we say the traditional tracker in which there is a one slew drive, and that will cause the higher deflection. And if we store those trackers at 0-degree position, then that tracker's critical wind speed will be lower, and that is why traditional tracker will not be storing at 0-degree. It will store at 15-degree to 45-degree position or 60-degree.
Mhm. Okay, great. Thank you for that. And obviously there's a good, let's say, energy yield advantage in this case, right? That is significant in the areas where there are wind speeds that could reach, let's say, the 20.
Yeah. So yes,
Mhm.
at a 0-degree position, there is another advantage that the wind pressure will be very low compared to stowing at different position, and that is helpful for the module also, because module will have less chances of cracks. Okay, because the wind pressure on the module will be also low. So it is good, win-win situation for the tracker as well as for the module.
Great, thank you for that. I have a question from Mr. Werner Warmuth, who asked, like, I don't know if you have that on top of your mind, Amrendra. How much kilowatt hours per kilowatt peak can be estimated as specific yield with the configuration of a single axis tracker with bifacial modules in Saudi Arabia on sand albedo? So how much more electricity would you generate for a one-axis tracker with bifacial modules?
Yeah. So it depends on the basically many factors. It depends on the ground condition. Also, it depends on the terrain condition, how much it is related. And if we use our artificial intelligence controller, okay, which is equipped in our tracker, then it is possible that we can enhance the energy generation more than 1% also, and it can reach even 5% also. Depends on the ground conditions.
Mm-hmm. Okay, that's great. I have a question from Mr. Yahya Al-Rawahi, who asks if Sky Smart 2 is like, if it was implemented yet, or it is still a new product for you. Do you have any installations with this product yet, or are you just introducing it?
No, we have already installed this project, and we have installed basically in Abu Dhabi also we are using this product, that in Al Dhafra project, which is 2.1 gigawatt in capacity. And we have used this tracker in other region also.
Okay, so it is now being installed in Al Dhafra project in Abu Dhabi,
Yes.
the 2 gigawatt project.
Yes.
That's good. So that's a like a massive track record for this technology. I think this answers the question. Thank you, Amrendra. Then with this, I'll get back with a quick question to Muhammad, and we'll get back to you, Amrendra, with a couple of operational questions that we have received. So we'll put that together for you in a minute. Now, Muhammad, we have a question from Mr. Muhammad Hosni, who asks if, it's a long question, I'll try to summarize it, that if you have, like, how can you predict or thermally insulate PV systems so to reduce the impact of the high temperature in the MENA region?
Now, this is the same question, for example, when you have in petrol engines or diesel engines, can you isolate the heat generated from the combustion process and you get only the benefit? The answer is no, you cannot, because solar irradiance coming with the heat, the same thing, the result of combustion process is also mainly heat. So for example, in the car engine, you cannot isolate the heat and you get only the benefits. So you have to deal with the heat. That's why there's a cooling system implemented to reduce the effect of this heat. So also the same thing for the solar module. The solar is exposed to both radiation and heat. You cannot eliminate the heat. It's exposed to the heat. So the thing that you have to do is to deal with the heat. How to with it? Now, first, when you have a newer technology, the newer technologies will operate at lower temperature than the older technologies. So this one of the way to deal with the heat. The second way is also to have a proper installation where you don't increase the probability of having hotspots. So you don't install near shading or during the maintenance. Also, don't have people walking on the module, because this will lead to microcrack. Then it will lead to hotspot, and the heat uh, will increase the possibility of having problems. And also to have a proper, if possible, of course, to have like a proper ventilation for the modules, where you put the modules a little higher, like 10 centimeter, 20 centimeter, if possible, above ground. So this will lead to a proper ventilation. So this is how you deal with the heat, but you cannot isolate, or at least on commercial scale we are talking. Maybe there are some studies going on where they have, for example, they are combining PV module with heat exchanger, so it will absorb the heat. Maybe this on a small scale can be implemented, but on commercial scale, it's not feasible. It's not possible so far. So you have to deal with the heat, and there are a lot of ways to deal with it. I hope I could I gave
No,
overview of this answer.
that's a good and thorough response, Muhammad. Thank you for that. Obviously, this is an industry, let's say, challenge, and that's why there's always improvements to the cell technology. So it is more, let's say, heat resistant, or let's say with lower temperature coefficient, which has been improved, let's say, significantly if we compare it to 10 years ago. One last question, please, Muhammad. Before I move to Amrendra, I have a question from Mr. Muhammad Ali asking, is there a price in, or let's say, like a difference in the cost of production or in the selling price for bifacial modules? And could bifacial modules be used to replace some building parts, like it can be used for cladding of the roofs of the buildings, as he asks?
Okay, so yeah, of course, there's a difference. Now look, on the cell level, the industry has unified the cell. So the cell for both monofacial and bifacial, it's more or less the same. So the main difference will be on the rear side. So the rear side, we are replacing the plastic polymer with the glass. So here will be, of course, we will have, because the glass is more expensive. So here there will be a difference in pricing. But of course, there's another benefit when you go with bifacial, because you have a thinner frame, so you can have more modules per container. So there's many things to consider. So it's not only about the increment in the pricing, but also what benefits you are getting in terms of generation and savings in shipping. Now, can you replace? Yes, but that's why we have something called BIPV modules. Usually, it's not very easy to replace a part, because you need to customize the part. So you will not have a part exact dimensions with the PV module. So you need a PV module with some modification or some uh, uh, special requirement. So it's possible, and this is the built-in integrated photovoltaic, where you, for example, instead of having a roof, you will have a PV modules on the roof, like a roof, the ceiling, different parts of the building can be replaced, but this, of course, can be uh, with special modules, not with the standard one, because the standard one, in terms of sizing or some specifications, may not be suitable.
Thank you, Muhammad, for the answer. I hope this answers the question. And move now to Amrendra. Amrendra, I'll start with the basic question so we can help more people to catch up with us. So we have a question from Mr. Khalid Bukairat, who asks, what is the main difference between the 1P and the 2P tracker in terms of applications, and if there are any, let's say, clear, segregators between where you apply a 1P or a 2P technology?
Yeah. So yes. So basically, 1P tracker and 2P tracker. Basically, if we compare 1P and 2P tracker, then we need to see the project locations. We need to see the ground condition also. Sometimes 1P tracker can be also a good option. Sometimes 2P tracker can be a good option. For example, if I am talking about 2P tracker, so it will be a very good options where we are getting a very challenging land, where we are getting rocky strata, where it is difficult to do digging in the soil. It is difficult to do excavation work. And in 2P tracker, we can, you can use list cost per megawatt peak, and that can help in reducing the foundation cost. And if the ground conditions are normal and we're not facing any challenges, then it may be possible that we can use 2P tracker. It could be 1P tracker. It can be more economical.
That's great. And now I come to the operational questions that I promised you about before a couple of minutes. The first question comes from an anonymous attendee, says that what is the cost impact for the O&M phase when we move from 1P to 2P trackers?
So there will be no there will be no such cost impact. So basically, if I talk about 2P tracker, basically 2P tracker is slightly higher in the height compared to the 1P tracker. So there will be slightly more installation cost. Okay, and otherwise there will be no extra cost impact in case of 2P.
Okay, so there's no increase in O&M costs for, let's say, 2P trackers, whatever they take that into consideration. The next question again is a little bit operational. It comes from Mr. Yahya Al-Rawahi, who asks, some projects have experienced misalignment of trackers due to variation in tracking angel change speed. How can this be resolved? I don't know if this is applicable to you in Arctic.
So sorry, what is your question? Can you repeat again?
So because of the high, let's say, wind speed, in some projects there was what the result was some misalignment in the trackers due to the variation in the tracking angel after as a result of the wind. How would they, if you have any advice to them, let's say, to deal with this topic?
Yeah, so basically, in case of the very high wind speed, so we need to have a tracker that stores at that stowing wind speed is higher. So for example, if we have a rigid tracker, then that tracker can deal the higher wind speed, because that tracker will have the higher critical wind speed. It means the stowing wind speed will also be the higher, and tracker will not go frequently to the stowing position. Okay, and it will be more stable and strong under high wind speed. Hello?
Yeah, sorry, I've been on mute. Thank you for the answer, Amrendra. I'll move to the next question regarding what is the adoption rate of dual access tracker in the MENA region. Do you see this at all? Dual access trackers?
Actually, so far we have not received any benefits of using a dual access tracker. Basically, in terms of cost, it is not economical. So basically, we need to see the overall, not only the cost, we need to see generation also. So maybe the dual access tracker will have advantage in terms of generation, but in terms of cost, it is not economical, and that is where we are not considering. We are using only single access tracker at this time.
Okay, I have a couple of, let's say, questions that are out of the box, let's say, and where people ask questions like Mr. Khalid Kerat again, who asks if there will be something after 2P. Would we have NP, like 3P trackers?
Yeah, so this is in R&D stage, so maybe we can come with 3P solution as well. But presently we have 1P and 2P solution, and that 2P and 1P both are very rigid tracker, and that can help in enhancing the generation.
Okay, we reached the end of time, but still there's also one interesting question from Mr. Hazem on LinkedIn, who asks if we can use trackers for special applications, not just for utility scale applications. Something he mentioned like for solar lighting in the streets or so. So do you see such applications for trackers in general?
Yes, we can use, but the problem is that it may be uneconomical also. So we need to see the overall case. If it is because we will for the solar lighting we will use a limited number of the trackers. So maybe it could be uneconomical.
Okay. That's great. So thank you, Amrendra, for the answers. I think we've reached now exactly the end of the session. This was a very informative session where I wish to thank both of the speakers, Muhammad Saadi and Amrendra Singh, for their generous sharing of information through their presentations. And that's why I received more than 10 requests from people asking for to get hold of your PDF files of your presentations. If you can share that, this will be uploaded to the website after the session, to the same registration page. And for those that registered on Zoom, then they will get that by an email within 2 days. So make sure that you check your inbox within the coming 2 days to get this delivered to you. I wish to thank everyone who attended this session. We had hundreds of people attending on Zoom, the same on social media, on LinkedIn, Twitter, YouTube, and Facebook. I'm very happy to have you all on board. I hope that you found this session informative. To learn more, get a better feeling about the 2P trackers and what advantage do they bring compared to the 1P trackers, and how the designs and of these trackers develop with time to adapt to the different challenges in whether it is the bigger size of the modules or the special environmental requirements for like high speed wind speeds and so on, like what we have in the Middle East and Northern African region and the African region. So thank you very much for attending the session. If you have any further questions to any of the speakers and you see their emails on the screen, please drop a line to them or send us an email to info@solarabic.com, and we'll make sure to share these questions with the relevant speakers. I'm very happy that we've managed to cover this difficult, let's say, topic within an hour. For sure, we'll be following up on this topic next year. We'll be happy to have both of Amrendra and Muhammad on board to speak about the new tracker and module technologies as we move forward. Last words for you, Muhammad. Amrendra, if you want to say anything.
No, nothing from my side.
Thank you very much. Thank you for the time, Muhammad.
Thank you. Thank you, Architect. Thank you, Solar Arabic, for the invitation. And let's hope to have a successful year ahead. Thank you so much.
Thank you
And
so much. Thank you.
enjoy.
Thank you for joining.